Hi there, in this video we are going to go over how to analyze linear and nonlinear functions. So we can analyze parts of a function by describing them as linear or nonlinear. We can also describe them as increasing and decreasing. Alright, so let's look. Describe the parts of the function as shown below. So first we're looking at between x equals 0 and x equals 4. So here's x equals 0 and here's x equals 4. So what is going on when x is 0 and x is 4? So we're looking at this line here, which I outlined pretty bad there. Let's try that again. So here's the curve. All right, and so since this isn't a straight line and it's a curve, we're saying that this is nonlinear and increasing. All right, and next it says what's happening between x equals 0 and, x equals 4 and x equals 8. So here is x equals 4 and here is x equals 8, and we need to tell what's going on right here. So since it's curved, again, this is nonlinear, and this is decreasing. All right, next we have a distance versus time graph. So let's go over a couple of those. So a distance versus time graph shows us how far two objects are from one another. What would the following types of lines on a distance versus time graph represent? So let's look and understand what's going on in A. All right, so first off, this is linear because it is a straight line, which means that there is a constant rate of change or a slope, right? So here, you'll notice that the distance, which is on this side, is increasing as time is also increasing, but it is doing so at a constant rate, and that's why we have a straight line. So here we say an object is moving further away at a constant rate. Okay, think of it like speed, right? This is moving at a constant speed. Rate and speed are interchangeable. Distance over time, miles divided by hours, right? Miles per hour. So let's look here at the next graph. Here at the next graph, the distance is starting from far away, right? And then it's going closer and closer and closer, right? The distance, this could be like 10 miles up here versus here now this is 0 miles. So it's going closer to 0 miles. So an object is moving closer at a constant rate. It moves at a constant rate because it's a straight line. If it wasn't straight, then we would say whether it's increasing or speeding up or decreasing, slowing down. All right, next we have here just a straight line across. When you have this, this means that an object is at rest or not moving, right? The object isn't changing distance over time. It's staying in the same place over time. All right, now we have a curved graph. And so since this is curved, it's not moving at a constant rate. Okay, this is straight, so it was constant, but now this is a curve. So it's not constant. It's actually, if you want to think about it, over time when you start, you're not moving too far, right? Over time, the distance remained very little distance between like you and the object. Okay, so from here to here, very little ground was covered. And then from here to here, a lot of ground was covered, right? During this time, so much ground was covered. So you sped up at the end. So here is an object is moving further away at an increasing rate. Okay, you start off slow. Here you start off slow, and then as you continue, you're going fast. And then here is the opposite. So if you look from here to here, you're covering so much ground, right? Your distance increases so much over this time. And then it kind of plateaus. So in this case, an object is moving further away at a decreasing rate. Right? You're starting off covering so much ground, and then you plateau at the end, so you're not covering as much at the end. All right, match each distance versus time graph with the correct description. So let's first understand each of these distance and time graphs. So here we're moving at a constant rate, and then we come to a stop, and then we're moving at a constant rate again. All right, here we're moving at a constant rate, then we come to a stop. Constant rate, stop, and then a constant rate. And then here we move at a constant rate, stop, constant rate, back to where we started from. Stop at where we started from, right? And I say that because here's 0. And then we move at a constant rate at the end. All right, so Haley got on the bus at her house. The bus made 2 more stops before it arrived at school. So here in this first graph, there's only 1 stop, not 2. So that wouldn't be the answer. The second graph actually has 2 stops. So let's see if this makes sense. Kaylee goes on the bus, and the bus travels and then makes a stop, and then travels again, makes a stop, and then travels again. So here it says the bus made 2 more stops before it arrived at school. So looks like A goes with 2. All right, B. Brandon and his dad left for school in his dad's car. They got stopped at the train tracks for several minutes before they were able to continue to school. So it just makes note of 1 stop. So between 1 and 3, this is where there's the 1 stop. So they leave for school, and then they stop at the train tracks, and so this is the stop, or they're at the train tracks, and then they continue to school. So B pairs with 1. And then number 3 then would be with C. So Cameron leaves for school with his mom, and then remembers that he left his English project at home. So he is here right now. This is where he's the point of his remembering. And then she took him back home, so now he's going back home to get his project. So here's where he's getting his project, and then they head home without any stops. All right, so C goes with 3. All right, the graph below shows Justin's distance from his house as he walks to school. Interpret what you think happened at each segment of the graph. All right, so in part A, it's a constant rate. So he's moving at a constant rate. So we're going to say Justin walks to school at a constant rate. All right, now let's look and see what's going on at B. He stops it looks like he stops because something is distracting him. So we'll say Justin stops because there's a goose in his way. And we'll say he swipes at it to shoo it away. All right. And so then at the end, C, you'll notice that he's not covering much ground, and then he covers a lot of ground, right? So in C, we'll say the goose chases Justin. So he runs to school at an increasing rate. All right, so he starts walking to school at a constant rate. He slows down and stops because he sees a goose. He stops because he sees a goose, and then the goose starts to chase him, so then he runs to school. All right, so that is all. Hopefully you learned how to analyze linear and nonlinear functions. Thank you for watching.